We already have seen the generic classes having only one type parameter. Can we have the generic classes having more than one type parameter? Yes, we can have that. Namaste everyone, I am Gyan and you are watching the session 21 of Java and Web, Generics in Java. Now look at here. Here we have the class first, which is having two type parameters, S and T. Here we are not showing the definition of the class first. In the another class, we are creating a new object of class first with two type arguments. Since the class definition has two type parameters, that's why we have two type arguments while creating an object of the class first. The first type parameter of the class first will become the first type argument, and the second type parameter of the class first will become the second type argument. The order of the type arguments at the left hand side should be same as the order of the type argument at the right hand side. For the JVM, both S and T type parameters are java.lang.object. As we have seen in the earlier videos of this session, for the JVM, all the type parameters are always java.lang.object. But the compiler checks the first occurrence of the type argument against the first occurrence of the type parameter, the second occurrence of the type argument against the second occurrence of the type parameter, and so on. We can have multiple type parameters and multiple type arguments. Therefore, the compiler checks whether the value to be stored in the variable of type S is a string or not, or whether the value to be stored in the variable t is an integer or not. As we already have seen in the previous videos of this session, let's look a real example. Here we have two Java files, first.java and use.java. In first.java, we have the class first, which has two type arguments, t and s. Then after, we have the variable s of type s, and we have the variable t of type t. We are assigning the value of s in the method setS, and we are assigning the value of the instance variable t in the method setT. Then after, we are printing the values of the instance variables s and t in the methods getS and getT respectively. After that, we have the Java file use.java. In use.java, we have the class use. In the class use, we have the method main. In the method main, we are creating a new object of type first with integer and string as its type arguments. So for the compiler, s becomes integer and t becomes string. Therefore, when we pass the string hello as the actual argument of the method setS, then the compiler allows it to be stored into the reference variable s of type s, because s is considered as the string by the compiler. But if we try to pass the value 10 as the actual argument of the method setS, then the compiler will not allow us to do it, and the compiler will throw an error because s is considered as an string. Therefore, we have commented out this statement, and since we have commented out this statement, therefore when we call the method getS by using the reference variable f, then the previous value of the variable s will be printed. That means it will print the value hello. If we try to pass the string as the actual argument to the method setT, then the compiler will throw an error, because in the method setT, the formal argument is of type t, and t is considered as an integer. As you can see, t is considered as an integer. That's why we have commented out this statement, and we are not assigning anything to the variable t, because this was the first assignment to the variable t which we have commented out. Therefore, when we call the method getT by using the reference variable f, it will print null, because still we do not have any value assigned in the variable t. After that, we are trying to pass the integer t as the actual argument of the method setT, and that we can do because t is considered as integer. Therefore, after this statement, when we call the method getT by using the reference variable f, it will print 10. Then after, we are trying to pass a reference of an object of the class use as the actual argument of the method setT. That we cannot do. T is of type integer. We cannot store a reference of class use. That's why in this case, the compiler will throw an error. And since we have commented out this statement, calling the method getT by using the reference variable f will still print 10. Hopefully you are getting my points. Let's try these codes practically. Here we have two Java files, first.java as we have seen and use.java as we have seen. Let's try to compile these two codes. The two codes are stored on the desktop. Java C, first.java, and use.java. Use.java. Compiles fine. Now run it. Java use. Executes fine and printing the expected output. This is the same case as we have seen in the earlier slide, but here we are creating a raw object of type first. We already know the raw object. When we create the raw object, then the compiler doesn't care that what you are going to store in the variable of type parameters. Therefore, in this case, we can pass anything as the actual argument to the method setS and the method setT. We can pass a string, we can pass integer, we can pass a reference of an object of type use. All will work fine. Here, after we pass the reference of an object of type use, when we call the method getT by using the reference variable f, it calls the toString method to execute and it prints I am use. So I hope you know all these things. We already have talked a lot in the previous videos of Java and Wave. If your generic class is accepting two type parameters, then you cannot use only one type argument. That is a compile time error. Let's try it practically. Open first.java. This is the same code as we have seen. Open use.java and just use only one type argument. The class first is accepting two type parameters, but we are using only one type argument. Now try to compile this code. Java C, first.java use.java. The compiler throws an error. Wrong number of type arguments required 2. Means the total number of type arguments required is 2 and we are using only one type argument. However, the diamond operator is allowed in this case. Means the type arguments at the left hand side should be same as the type parameters of the implementing class, but at the right hand side we can have a diamond operator. Let's try this practically. Open use.java. Let's use here string, string. Now we have two type arguments at the left hand side, but at the right hand side we are going to use the diamond operator. At this time the code will compile fine. Compile it, compiles fine. Now execute it. Java use. It executes fine and printing the expected output. If you are using the type arguments at both sides of the equal operator, then the type arguments should be in the same order. Means if at the left hand side you are using string followed by integer, then at the right hand side you always should use string followed by integer. You cannot use opposite. Now let's try it practically. Here in the use.java, instead of using a diamond operator or using integer followed by string, let's use something opposite. Integer followed by string. String, integer. Now in this case, the compiler will throw an error. Compile this code. Java C, first.java use.java, compiler throws an error. Incompatible types. First string integer cannot be converted to first integer string. So hopefully you got all my points. That's all for this video, guys. Don't forget to like and share this video. Subscribe my channel on YouTube, like my page on Facebook, and leave your favorite comments in the comment section below. Thanks for watching. See you in the next video.